All right. So I think we have fixed some of the bugs that exist on the sprint animation, plus some improvements to the locomotion transition state machine graph. So now I think we can look into much more advanced concepts like additive leans, orientation warpings, distance matching, things like that. To get a start, I think maybe we can start from the additive leans onwards, and then progressively let's cover much more advanced concepts. Okay, so additive lean means something like this. So I think inside the animations we have these lean animations. If I show you what we have in those, basically the lean scent animation is something like this. We have sort of a repeating animation, and for the lean left, sorry, this one is lean right, we have this animation, and for lean left we have this animation. So this is just a one frame animation where we can use to improvise other animations based on this specific additive animation. Okay, so first I think what we have to do is we have to make these animations as additive, right? So let's see how we can do that. Okay, let's go to the TPS game essentials, character, mannequin, animation, lyra, locomotion. Let's search for lean. We have these three animation for leans. So I'll start with the center, and here we have a section called additive settings, and by default is marked as no additive, but let's make it as local space additive animation. And for the reference I'll add selected animation frame, and for the animation I'll assign this center animation as the reference base pose. Okay, and I think we can disable root motions as well, right? Because we don't need to manipulate the root bone of the character when you are playing these additive animations. So similarly for juggling right, let's make it as local space selected animation frame, and make sure to put lean center as the base pose, not this one, because as the base pose we should always have a reference pose which is exact same, right? Because based on that reference pose onward, then the additive animation will be applied for this specific frame, right? So for juggling right, make sure the base pose should be juggling center, and let's disable the root motions. And similarly, let's open up the joglin's left. I'll make it as local space selected animation frame. This one also lean center, and let's disable these two. Okay, now based on these three animations I have to create a 1D blend space to blend each of the frames smoothly, right? So I'll go to the, I'll remove this search reference, and I'll go to TPS game characters animation folder. Let's create a new folder called blend spaces, right? And here we are going to create our very first blend space, which is type of blend space 1D. So do we have 1D blend space? Yeah, under the legacy category we have blend space 1D. So let's choose that one. And for the skeleton, it should be SK mannequin. Which one? Yeah, SK mannequin. And let's name it as BSMM. So this one is for leans, right? MM leans. Right. And I think these leans actually follow the rifle animations, because by default the Lyra provide these three for us. But I think it would be fine, because we are going to, most of the time we are going to manipulate the existing animation based on these frames. So therefore it doesn't matter whether it is rifle or unarmed or pistol. You just need this angle and the reference frame, right? So that's why actually I named this as BSMM leans as a generic format. But let's see how we can do this if something goes wrong. Okay? Right. Then as the horizontal axis name, let's make it as lean angle. And the angle should be clamp with the minimum value of -20 and the maximum value of 20. And for the grid divisions, actually I think 4 would be fine. And yeah, that's almost it what we have to follow. And since this is additive animation blend space, let's apply this jog lean center to this. Oh no, maybe not. Maybe let's reset this thing. Maybe we can apply any sort of animation to here to make a reference out of it. Okay. Right. So let's first add the center to the center. Right. And you can see now the mesh has been gone, because this is the additive animation. And you can see at the preview base pose, it is automatically assigned to this center animation. But since this is additive animation, it is not visualizing properly. So instead of that, let's maybe assign rifle jog forward. Now you can see it plays animation with the base additive reference pose. And similarly, let's add right to right and left to left. Now I think we can make it as maybe snap to grid, so we won't fall any sort of intermediate points in between these timeline. Okay, now let's reset this back to rifle jog forward. And here now you can see when I'm moving this node in between the timeline, that additive animation has been applied, right? So you can move this node actually while pressing the left control of your keyboard, right? If you have the default key input mappings for Unreal Engine, and you can see how it's been applied. Maybe just for testing, let's try unarmed jog forward as well. Right, I can see even for jog that additive animation has been applied. Right. if I show you, see, now the leans has been applied. So the goal of having this lean is basically when we have a like, let's say, turning point, then instead of directly going to that direction, we can have sort of a lean to that specific angle, so it will be much more realistic, like in real world scenarios. If I show you currently, let's say I'm going forward, and if I'm trying to go to right side, you see, still the character is falling under the same cycle animation, which is fine, but it's not realistic enough, right? But if we have the leans, what will happen is that when we are changing the target direction, something like this, forward to right per se, then it will apply a slight lean toward that direction and manipulate the existing cycle animation accordingly. Okay, so now we have this BSMM leans blend space. Now what we have to do is basically we have to get this blend space inside our data table where we can access it later on. Okay, right, first let me quickly check my documentation. Yeah, so let's first go to the data structures, locomotion. Inside general, we have this is anim general. Let's open this thing. Now I'll add another variable called leans, right? And this should be the type of blend space 1D. And yeah, now since this is a data structure change, make sure you are properly recompiling the appropriate data structures. So since we manipulate this data structure, the next parent we should compile, which is this one, right? So it's good to go. And then go to the data table and save it, and finally save all, right? And if I go to the PPC location system, compile it again, now there is no any structural inconsistencies, right? Okay, and then let's go to the DT and imset data table, and here we have a new field called leans, so we can assign this PSMM leans blend space 1D a graph to it, right? So we have that in here, and then what we can do, let me quickly look at my documentation. Yes, and then let's access this variable inside the ABP locomotion. So I think inside the inside not thread safe functions, we have the set animation data, and similarly we have been done to these prints. I'll copy these two, paste it here, copy and paste it here, and I'll promote it to a variable called leans, right? And let's collapse nodes, and I'll rename it as additive leans. Okay, now what we can do, yes, now let's go to the anim graph. Inside the locomotion cycle animation, we can add that additive blend space animation here. But first I think we have to add a new node called apply additive, right? And for as the base pose we are passing the existing cycle animation, and as the additive animation let's pass our blend space layer, right? And I think we only need to manipulate the x-axis, not the y-axis, so we can disable exposing it like this. And what we can do, yeah, plus we need to expose this blend space as a pin, right? So let's mark it as expose as pin, and now we can plug that leans variable to here. And I'll move this to anim sequences category as well. Yeah, right, now we have that leans here alongside the base pose, right? So currently the x angle is 0, so if I play test it now, you can see it's simply a straightforward animation. But if I make it as 20 and play it again, you can see once the cycle animation has been played, it is a bit leaned towards to right axis, right? And if I stop it, it will go back to the straightforward state, because at the start we are at the stop animation or start animation, we are not improvising any sort of additive leans, right? And similarly, if I mark it as -20 and play it again, you can see start animation is fine, but once it reaches to cycle animation, now it's lean towards left. And if I stop it again, I disable the lean, right? So now that additive leans is applied, but ultimately we shouldn't manipulate that specific lean angle like this manually, right? So this should be dynamically resolved at the runtime, which means like whenever we have a turn, this x value either should increase or decrease based on that rotation direction, right? So now let's see how we can calculate that additive lean angle, right? So first I think we have to go to where inside the blueprint thread save functions. Yeah, we have this update rotation data function, and currently it's recording the world rotation only, and here let's calculate the additive lean angle, right? Okay, so yeah, so I'll move it bit here like this, and I'll get the reference from this get at rotation and break the rotator and get the world rotation, which is at the world rotation category, and break it as well, right? So we have these two. We only need to consider the yaw, so I'll subtract the yaw like this and then promote it to a variable called yaw delta since last update. So basically what this variable capture is, it will capture the delta difference between the rotation based on the current frame and the previous frame. So the previous frame rotation actually captured at this variable. So this is that one, and the current rotation will be captured from here, which is this property access pin. And if we subtract the yaw, then it's a yaw delta difference, or yaw delta basically. Right. So let's call it like this. Plus make sure to call this variable initialization before this world rotation has been set, because in case if you call it here like this, then what will happen is that basically it doesn't aware of this first frame, right? Therefore we always have to call it like this after the first initialization. Okay, and similarly can get the delta seconds out of it, and let's safe divide. So safe divide basically is a division that has been applied for like let's say any sort of a division, but the safe divide is exact same for that divide function, except whether the b is 0, then it simply returns 0, right? So it is sensible for the denominator value, because in case if the denominator becomes 0, the output return value will go to the infinity, right? Which is not ideally what we want. Therefore let's make sure to use a safe divide, then such edge case scenarios won't be happen. Okay, so let's divide it like this, and let's promote it to a variable called your delta speed. And this one also, both of these go to this world rotation category. Okay, now we have your delta speed, and then basically based on that, now we can calculate the your delta, right? So I will multiply this by some value and promote it to a variable called additive lean, and push it to the world rotation category. And this additive lean angle should be multiplied with a certain set of numbers to make it much more smooth, right? So I will select set of floats values, and let's say if we are crouching, we should have sort of a like a reduced lean, right? Because we are not moving fast. And let's say if we are walking also, we should have sort of a reduced lean, because both crouching and walk speed has both crouching and walk states has bit of small speeds. Therefore we don't need to improvise a higher lean delta. So how we can do that? Basically we have this character state data, and let's check whether it is crouching, or we have this locomotion state data, we have this ls movement type. So if you are walking, then we don't need to have a higher lean delta, right? So I'll assign like 0.025 for such scenario, and all the other scenarios, like let's say jog state, then we can have sort of a higher lean delta. So I add 0.0375, right? This number is larger than this number, therefore the multiplied return value will be large. Okay. Okay, now we have the additive lean animation that has been captured. Not the animation actually, the variable value. But at the very first update or very first frame update, this your delta since update variable and the your delta speed variable should be initialized as 0. Actually, not this one, this one and this one. Right? So how we can determine whether we are remain at the first frame or not? Okay. Yeah. So let's add another variable called is first update, and I'll assign this to category called frame checks. Right. And by default I'll mark it as true, right? Which means like at the very first frame, now we know whenever we initialize this ABP locomotion graph, at the very first frame this one is true, but after that initialization this variable should become false, right? Because now set of frames has been rendered. So how we can mark this as false? Basically we have this blueprint thread safe update animation function, and at the very last of each calculation let's mark it as false, right? So at the very first frame this is true, and from the second frame onwards after this initialization it will mark as false, right? Okay, and then let's go back to the update rotation data function, and there let's check whether this is the first frame, and if it is the first frame, let's mark this as 0 plus this one as 0. Right, so at the very first frame these values will be 0 by default, and from the next frames onwards these calculations will be applied and these variables will change accordingly. Okay, now let's go to the anim graph, locomotion, cycle state, and here as the x value I think we can plug that additive in variable. Additive in. Okay, so for the debugging purposes maybe we can go to this blueprint thread safe update animation, but I think we can't apply the print here because this is a thread safe function and the default print is not actually thread safe. So I suppose we have to go back to the event graph. And do we have an event for update? Yeah, we have event, and let's try to print the value for this additive lean angle. Then we can see actually what happens when we make a movement change. Okay, now let's play. So you can see by default it's 0, but whenever I start to rotate it goes for a specific value, but once that rotation has been finished it will go back to 0, right? So if I move to the right side it's a positive value, and if I move to the left side it's a negative value. Okay, right, now let's try to Yeah, you can see if I try to move right side, now that lean is applied properly, right? So if I slowly move, then a smoother lean is been applied. But if I try to move rapidly, you can see a higher lean has been applied, right? And similar for the left side as well. Now the lean is applied properly. Okay, but I think sometimes there is sort of a jitter effect. As you can see, sometimes the animations are jittery, right? And let's see why. Right. So I found where we have to make a change. Basically, let's go to the BSMM lanes blend space, and here you can see there is a section called sample smoothing, right? And by default, actually the weight speed is 0, but I think we may need to increase this further to have a proper, smooth uh, lean, right? So I think 3 would be enough for have a proper smooth lean. And let's play test it again. Yeah, now you can see there is no more jitter effect, right? So we have a very nice looking smooth lean, right? Okay, great. So that works properly. Okay, now I think we don't need this stuff because that was added just for the debugging purposes. And let's make a final playtest. Yep, that lean works nicely. And let's try the crouching as well. Yeah, you can see like for crouching also the lean has been applied, but it's pretty much small, right? Because if you remember at the BP locomotion, whenever we are calculating this additive lean angle, here we are mark it as 0.025, right? So if you are crouching, it's a smaller lean, and also for walk it should be a smaller lean. So let's try walking. Yeah, here you can see for walk also there is relatively small lean that has been applied. But if I try to jog, now we have a higher lean. And also for sprint, I think the lean is applied properly, but it's almost not noticeable because we are moving very fast, right? But here you can see for sprint also the lean has been applied. Okay, so that's how we can add additive animation for our locomotion system at our TPS game. And I think that's all I have to cover in this tutorial, and I'll see you in the next one. Thank you.